Okay, we're going to look at some testing here, some prime number demos. Okay, uh, know what a prime number is? A whole number greater than 1 that cannot be exactly divided by any other number other than itself and 1. Some examples. 2 is always a prime number. 3 cannot be divided by any number, can't be divided by 2 or 1, or 2. 4 is a prime number. It can be divided by 2. 5, it can't be divided by anything. 6 can be divided by 3 or 2. 7 can't be divided by anything. 8 can be divided by 2 or 4. 10 can be divided by 5 and 2, so on and so forth. Okay, that's what a prime number is. Okay, I did this way back in the 80s. I wrote code in BASIC and an assembler just to see the speed difference on a COCO I. And I played around with it, and that code's long gone in the Bitbucket. Don't know where, when, or how back in the 80s. And here, for some reason, I thought I'd give it another shot. So I wrote it again in BASIC and assembler. Okay, I did it on a COCO III using the emulator mess with the high-speed poke. But the programs, both the BASIC and assembler, should work on a COCO I and II also. So, all right, before we go, let's look at the actual code. I had it all done, and I said, I want to see what AI will do. So I'd give it a shot. I think I'd used ChatGPT. It could have been Google Gemini, but I'm pretty sure it was ChatGPT. And I typed in prime number code using 6809 assembler on COCO with display. Even with the misspelling of assembler, that's what I typed in. So let's see what I got from AI. Okay. Everything from here up, I did not. I just took it and I assembled it right away, and I got a bunch of errors, but I just copied a few of them. The main ones is bad opcode. There is no opcode divide. Okay, divide you. That's bad. So I just put them in. There's a lot more errors, but it did assemble. Excuse me. So let's look at that code real quick. Got some routines, some date areas. Okay, down here. Uh, Here's where I think the first thing I did was jump to start. Okay, well, here is start. Load up with 2, jump to a routine called is it prime, yes or no. If it's not prime, go to not prime. All it does is bump to the next number, compares it to 100. So it's only looking from 2 through 100. Okay, so it's just going to keep doing this loop real quick. If it is prime, it's going to load up this message here which says prime, and jump subroutine, put that string out. The number that it says is prime, here, jump to a routine called to ASCII or to ASC, and that is here. It takes that number and it converts it to a printable ASCII string, takes what the result of that and prints it out. It's a routine called outstring, and a carriage return on line feed. Then it will bump that by 1 and go to the next number. Okay, that's it. That's what the code had put out there. Now let's actually look at the code. The code itself, the logic here is good. If you're building a flow chart, the object, it is good. It's just what you need to do. It's not very complicated. But now let's look at the code. Okay, jump subroutine is prime. If it's not prime again, okay, if it is prime, let's go right here. Put that message out, which was said prime to outstring. What is that? It's got some ROM routines in here. Out character equated A002, output character string. That is correct. It said this is a link to that routine up in memory. Now outstring A006 and carriage return line feed A08 are pointers to routines for the cassette recorder. Yeah, I know, but this here it says to the screen, these are wrong. That does not work. So we got outstring does not work. Load up U with this uh, buffer where to print this and go to this routine called to ASCII. Okay, this routine here is not bad. Not bad. It's got some problems. Okay, just like this first two, it does a push. Then he says load B and store B. Okay, them instructions should really be down here after this LAU 4 comma U, but that's okay. It's got some problems. Here's the next. Here's the big problem. Load U with U. I know what is that all about? Then we do something else. We got load X with X. That don't work either. Then we're going to load this up with 10, the mod 10. So we're going to divide. Here's that divide instruction. Divide D. No good. No, after that it's fairly good that there, except here transfer A to X. That's an 8-bit to a 16-bit. That's no good. And down here, this instruction is LAU 1 comma U. Well, it's no good because if you did it, it's just next thing it does is just pull U off the stack. So that it's not bad. It needs to be fixed, but it's not too bad. Uh, the only other thing is the one that it checks. It says, "Is this prime? Yes or no?" Okay, let's look at that one. Come in here with a number, and if it's a 2, say it's prime. Just clear B and go back. That's simple enough. But if it's not the 2, we're going to load up U with the 2, then load X with this mythical X. Can't load X with X. Then we got this divide U, which that's a bad opcode. Then it said multiply. Remember, multiplies A times B for some reason. Compare D to the X guy. Okay, and then branch equal not prime. So this 1, 2, 3, 4 instructions here, I think I know what they want to do, but that none of that works. It's just there's a whole lot of reworking in there. We'll load up U again, and here's to compare that X guy again. Okay, and it's going to determine one way or the other if it's not prime or prime. Okay, so that's the code. Okay, it doesn't work. Okay, the logic is okay, but at least 50%, probably more than that of the code is not very good. I took the code and I copied it over and started making changes to it to see if I could get it to work. So I added some stuff. I included, well, the stuff I provided you with was a common include. Okay, didn't need this backlab here. And one other thing, this code over here did not put an end statement on here. Okay, which you'd have to, it wouldn't load correctly if you ever got it to compile correctly. So I added some stuff to it. I kind of kept as much as I could intact. Okay, we got the start, and I'm to the store. I went a new field called store X and a number. That that number could be the mythical X in that previous program. I know I stored it there. Jump subroutine is prime. Okay, now is prime. Well, let's go on. Let's go back over here. But it's not prime. Bump it like it did before, and compare the loop to 50 instead of 100, and it just bumps it by 1 and saves it. All right, if it is a prime number, load up that message again and jump to put line, not to the cassette recorder. Load up some parameters and jumps to this ASCII routine, which was, I said, wasn't too bad to clean it up. I was able to clean it up pretty quickly. Here's I'm putting in what the parameters are. Okay, we're going to fill a field with ASCII zeros. Okay, and then we're going to put a null terminator at the end of that field. We're going to decode that number backwards. Load up 10. It's a mod 10 jump through subroutine. Divide xy. Okay, it's a routine that I use all the time. Okay, here it is in its entirety. It takes the dividend in x, the divisor in y. It does the divide. When it's done, your quotient's going to be in x, and any remainder will be in y. So you just come into this routine here, and it comes back to you. Okay, so that takes care of that divide thing that we had. Okay, so it comes back. We have remainder in y. We transfer y to d. because the remainder is always going to be just 0 to 9, so that's how we're dividing by 10. Make it an ASCII printable character, store that character in that buffer, then back up one, and go through this convert. Keep going to it until X is 0. That's it. And we got our ASCII fields to print. We got up here. If it is, we'll take that field we just created, we'll put line to the screen, the carriage return, and bump them to 1. Okay, so that's it. The only field left, or the routine left, is prime. At this point, I pretty much had it where it would print. I took this is prime field during the getting it to print correctly, and what I did was I asterisked out this divide U and multiply, and any place where it had compare D to 1x, I made it XX, XX. Okay, and I put just a dummy field up here somewhere. XX, I didn't know what it was, so I just put that in so I could get it through. So is prime does not work. If you come into this routine, you come out of this room, it says it's a prime number every time. But I got tired of screwing with it, so I got it to where it printed right. So much for that. So much for AI. Okay. Use it with a grain of salt. There hasn't been enough activity on the internet for assembler language on a Color Computer 3 to be very smart, so use it wisely. If you use it, it might give you an idea of logic, but the code is not too good. Okay, I'm going to pause this thing here. I've already got other recordings, the testing of all the things I did, the basic program and the other programs, so I will patch that into here and get back. Okay, let's do some testing. First thing I have is that AI program that I did. I modified to print the screen. It didn't check to see if it was a prime or not, but it went. So I'll execute that and show you that it really I did get it to at least print. It thinks every number is a prime, but anyway, I did get that AI program to work. Okay. The other thing, I have the basic program. It does prime numbers, so we'll run that. The limit will go from 2 to 200, and I got a Windows timer here that I'll try to click start on it about the same time I hit the enter key here and see if we can get a timer on this. Okay, we've got it going. It'll stop at 200. You probably don't need the timer. You can tell the speed just by looking at it when you see this in the assembly language program. This should take about 20 seconds. Hit stop when it gets there. 20.3 seconds, which is very, very consistent with what I've had in the past. So that was the basic program. Now let's load up the other one. All right, we'll start at 2 and we'll end at 200. Okay, we'll clear this timer out, and we'll try to get this going here at the same time. Now, 1.8 seconds. That's pretty consistent. It's always been about 1.8 between that and 2 seconds. So we had 20 seconds on the basic program and 1.8 seconds on the assembly language program. So let's clear that timer out. Let's run this one more time. Started at 2 and we'll go to 1000. Okay, we'll see if we get a timer on it. It runs pretty fast compared to the basic, but I will tell you one thing: once you get into the upper numbers or bigger numbers, it gets really bogs down. 18.9 seconds. So it'll go to 1000 in about the same time that basic goes to 200. Remember, what this does is it looks every number, so the bigger number you get, like when you get up to 1000, it has to go through 2 all the way up through 9999 to see if there is a of a divisible number. Of course, we're excluding all even numbers, but it's still 500 of these divides and checks and that and stuff like that. So if you put it in there at a big number, which I will do again just for, let's put in here 10,000, max number 10,100. I remember I put the check for a keyboard hit, but you'll see how slow this thing goes compared to the other one. It has to go through there many, many, many times to find something. I'll hit the space bar and we'll break out of it. So anyway, it is definitely much, much slower than the basic program. Uh, that's that's it. We'll go back to prime time, what we were doing before. Finish this out and see us back there. Okay, we're back finally. Look at some code. All right, first thing we'll look at is the basic program that you've seen in the test. This is it. It's the whole thing. I should work on color computer 1, 2, or 3. If it's on a 1 or 2, take out the high speed poke and the low speed poke, and it should work. This is not optimized to the extent it could be probably, but you can play with it. And all it is just two for loops of for loop 1 and 2, and it does it all right there in that little bit. So, and it works. It goes through. It's slow, and you've seen how slow it is. Let's look at the assembly language one, completed one that I had done before the AI thing. So it's kind of standard stuff. Get some stuff down here, direct page. Here we get the input number, your minimum from the keyboard, and convert it. We get the maximum and convert it. And here we start our loops, our L1 and L2 loops like we did in the other ones. 2 is always prime, so we're going to start with 2. So if it is 2, we'll just put a dot on the screen. Go to a thing called got one. It prints it, converts that number, and does that to ASCII thing and puts it to the screen. Nothing magical about that. Well, if it's not, it will do this bit B, and we only want to use odd numbers because any even number can be divided by 2, so we're going to skip messing with all anything that's not an even number. So if it's an odd number, we'll go forward here. If it's an even number, we'll just print the dot. So here we're going to get down here to this loop. So here's our loop. We'll get I got to put this in here. It takes up a lot of it takes up cycles to see if there's any thing that on the keyboard, if you listen, because if you start this thing, this example, if you put the minimum number is 10,000 and the maximum number is 10,005, you'll be sorry. No, you'll be sorry. You'll be rebooting your machine because it really, really bogs down when it gets into the bigger numbers. I mean, it will do them, but it really, just try it. Put in there 10,000 and 10,010 or something like that. You'll see how slow it gets. So, okay, it does okay. So anyway, it's going to check the keyboard if anything was put in there. Then we get the dividend and the divisor, and we'll do that same divide XY routine. See if there's any remainder. If there's no remainder, it's no good. It's just print a dot. It's not a prime number. And we'll just keep going through this loop. Okay, that's it. Just keep going through this loop right here. If we got one, we'll convert it and put it to screen. If not, print the dot. Okay, here's what the keyboard. Here's a to ASCII routine, which is very, very. In fact, I had another routine in here after I looked at the one in the AI stuff, and I changed it. I kind of used it as a model and redid the one I had in here because it seemed to be more efficient than what I had before. Here's the divide XY routine, and we also got the decimal in routine. What that is you type something on the keyboard. Okay, here's an example. You type in ASCII characters 1, 2, 3, 4. Well, you want to use that. You had to convert it, converted output would be $42D. So this is a routine that will do that for you. Okay, when you type in something on the keyboard, it will do that. And at the end, we got some other code. That's the code. Okay, you've seen the examples of it, the speed of it. Uh, I'll scroll through here one more time. And again, this here was that common that I've provided with you in the past, a common include, okay? And the MacLight I've provided with you in the past, okay? Other than that, I'll go through here and you can, if you want to, you can type it in and play with it, okay? It's, it's fun to code and see the difference in the speed. After that, it will probably end up forgot about and go into the bit bucket someday. So that is the code. All right, I think that's it. Okay, it was an exercise. Again, AI doesn't seem to work. It might give you logic to something, but I don't know about anything big, but use it at your own risk. So that is it. Uh, yes, that is it. So thanks for looking, and we'll come up with some other demos in the future.